Hi everyone, this is the Gyro Boy made with the Lego EV3 kit. On top is the brick, that's the brain. Over here is a visual sensor that records color, and this is an acoustic sensor. The thing is built to balance on two wheels using a gyroscope in the center, and those are the two big motors. And we're going to run the program and see what happens. Hopefully he'll wake up. There we go. He moved away from his stand. And now he's balancing on two wheels, which is pretty crazy. So it's making these little adjustments using the gyroscope. I'm going to use colors to make him move. I'm assuming it's a he. Green. Here he comes. Stop. Using the red. I'll put blue, and then I'll initiate a turn. Pretty crazy stuff.
Welcome to another video from explainingcomputers.com. For a while now, some of you have been asking me to make a video about a tiny little computer called the Raspberry Pi. And so, this time I'm going to do just that. The Raspberry Pi is a low-cost computer which was created to help people learn programming, but which can be used for all kinds of things. As you can see, it's about the same size as 12 real raspberries, but unlike the array of fruit, features a system-on-a-chip 700 MHz ARM processor. It also comes in two versions, called the Model A and Model B, which sell for $25 and $35 respectively. Here I've purchased a Model B, which has 512 megabytes of RAM, 2 USB ports and an Ethernet network port, a micro USB power connector, an HDMI socket for connection to a TV or computer monitor, as well as RCA video and audio jacks as an alternative means of AV connection. On the underside, there's also a standard SD card slot, and on the top, a set of GPIO or General Purpose Input-Output pins, which can be programmed to control all kinds of things. To make a Raspberry Pi work, you'll need an SD card to store its operating system, programs and data, and here I'm using a 16GB SanDisk Extreme, although any card from 4GB upwards will work.
Although a capable computer in its own right, the Pi won't run Windows. Instead, you'll find various flavors of Linux, and there's even a version of RISC OS and Amiga OS that have just been made to work on the Pi. Apologies if you weren't born in the 80s and have no idea what they are.
The Raspberry Pi has enthralled the STEM education world. A tiny credit card-sized computer for $25, hobbyists, students, and nerds are snapping the Raspberry Pi up by the millions. And they're doing some amazing stuff with it. Computer game clones, entertainment systems, teaching kids how to code, and feeding their pets over the internet. It has been embraced as a computer, but it has even more potential as a robot. Our dream is to turn your Raspberry Pi into a robot. And we will do that with something we've made called the Brick Pi. The Brick Pi combines the hackable computing power of the Raspberry Pi with easy-to-build modular Legos. The Brick Pi makes robotics with Raspberry Pi simple. The Brick Pi system consists of 2 parts. A board that slides over your Raspberry Pi and connects it to Lego motors and sensors, and a plastic case that connects your Raspberry Pi perfectly with the Lego technique. If you can dream up a robot, you can snap it together. Lego makes building the robot easy. The Brick Pi unites these 2 systems together so anyone can make an awesome robot.
This is the Northern New York FTC Championship event. We have 27 teams from throughout the Northeast. They're competing, typically a team is 10 to 20 students and a number of coach mentors, and they design and build a robot made out of metal and plastic Lego parts.
And these robots have to play a different game every single year. And so they build a different robot every year, they have a different kit of parts, and they have a different set of rules every year and a certain amount of time that they can do it in. So this year's game is called Ring It Up. They actually have to pick up these little rings, and they have to put the rings onto a rack. And the rack gets different scores based on the different levels. There's all sorts of different points involved.
Students, teachers, and now even the government's really figuring out that STEM education is critical. If you want to get more jobs available, you want to have people to fill those jobs, you've got to have the resource available. And the critical part is to start them young. So you start them immediately at the Lego age. They're 5, 6, 8 years old, and they're playing with Legos, and it turns out they're playing with robots. They find that it's fun.
I see today as actually building a pipeline, and to build a pipeline you need partners. And the pipeline we're building is to provide the graduates from institutions like Clarkson that are critically needed for the economy. We know that we need people in science and technology, engineering and math, the so-called STEM areas. And to build that pipeline we need partners. It's not just the educational system, K through 12, that we have to bring on board and have the part of the pipeline ourselves, higher education, but we need companies that both support financially and also they're the ones who our STEM graduates are going to go to work for. And so companies, I particularly mention Time Warner Corporation, their project to connect 1 million minds is really important. New York Power Authority, National Grid, all these companies jumping on board. That says something to these students that are interested in careers in the STEM fields.
Every student that gets involved in this program gets the experience to be inspired, to work with great mentors, to work with teachers and other students to really develop their technical skills. And that's really the whole point of the program. Who wins this tournament really, in the end, doesn't matter. It's nice bragging rights, it's fun, they may get to move on to another tournament, but in the end, the whole point is really to get the students inspired. So it's a lot of fun either way, and all of the teams have a great time. Just to see the robot do something for the first time on a real field is really exciting.